Good day, everyone. My name is Godfrey, and I'll be speaking on the geothermal system for heating and cooling our buildings. We are Geotech, so in our project, this is what I'm going to look at. Introduction to introduce the word geothermal is objective methodology, site identification, resource assessment, engineering and system design, economic analysis, and finally conclusions. When we talk about geothermal heat pump, we are all talking about how to use the underground heat from the earth to cool and heat our building. So when it's winter, we know our surrounding is cold and the earth is hot. So we tap the hot from the earth to cool our building. And when it's summer, the rivers happen, our surrounding is hot, and we tap the underground cold to cool ourselves. So what is our objectives here or introduction? Our goal is to use this system to operate on our existing building called the Mineral Science Engineering Complex at New Mexico Tech. The goal is to reduce the cost involved in purchasing power supply for heating and cooling and also reduce carbon emission. This is our objective. The primary objective is to propose a design for geothermal heating and cooling system, and also, as I said, they are to contribute in reducing greenhouse gas. So, our workflow is site identification, geothermal resource assessment, economic analysis, engineering and system design, input from stakeholders. So, this site identification, this MSEC burden over here, located in Socorro, New Mexico. It's a three-story building of one-story building making of a capacity of 24,400 feet. So we multiply by that three, give us the total. First floor is made of 4 classrooms, 16 laboratories, and 16 offices and 4 restrooms. They are all quite similar to the other floors, the second and third floor, just a variation in numbers. Now, this is a map of New Mexico, and this is specifically looking down Socorro. There is a Bureau of Geology. Just above the Bureau of Geology is MSEC, Mineral Science and Engineering Complex. So we quickly move to resource assessment. What are the resources that we have? So now we are capable of running a geothermal system. So New Mexico Tech has a high heat supporting system. You have the Rio Grande Graves, a natural system that is speak about the rifting of the core mountain, meaning that exposing the heated part of the earth closer to the surface. We have mountain ranges that help us to recharge our aquifers and rate the rain. So this picture over here is how typical for the Santa Fe group, that is showing how the heated core mountain is flowing up, and therefore good resources for us to have to create a geothermal system. This also is called about aquifer with a very high temperature gradient. This was a plot of data taken from the New Mexico State of Engineer. Based on these research, we were able to extrapolate to get the geothermal gradient just beneath our location, New Mexico Tech, behind 20 feet behind the building, the temperature gradient, and we saw it was conducive enough for us to run the geothermal system. This is a mud flow or heat flow of how heat is being exchanged or heat is being distributed underground through New Mexico, more specifically Socorro. And the one in the orange box is the town Socorro and our place of interest that we have chosen is Socorro. In that place having high mixture of high red and blue, means they have a very high heat potential and a good system for geothermal. This is a plot showing how we consume heat for heating, and the next one is for cooling. Now, this is how our system goes. We aim to drill 2 wells. These 2 wells, which was the picture from one of the videos that was made for the geothermal challenge, that direct heat, and since it was similar to our model, just to place there. So this where it's coming from. So there was a production well tapping the heat, go to the heat exchanger, required amount of heat is being regulated, then you go back to the system by the help of a pump. Then after that, we reverse back using the injector well to inject the fluid that has been cooled back into the system. So it's a direct heat system. Now, this the identification or the IDs of our well. We want to go 206,000 feet or 800 meters and 9070 feet for the injector. And this is the well ID, the location where you can find it. I want to put it at a flow of 50 gallons per minute. This is a schematic showing how we want our well for both injector, injection, and producer. And this is the well identification or things are going to look to see, oh, yeah, this we select this kind of well because of these reasons. Protect our aquifer, isolate, contain geothermal fluid, and the purpose of everything. So we come to it, we need to conduct whatever heat we are generating into the already existing system to operate. So we choose a carbon steel because it was the carbon steel is high thermal conductivity, and the carbon steel has an excellent strength and can withstand high pressure. So that was the reason. And when it comes to the insulation, we choose the foam because it insulates and they're very low thermal conductivity. That means that it doesn't lose heat easily. And use the heat exchange frame since it's already existing system over there. In order for us to help us to save money in the process of implementing a geothermal system, because we already have it there, why don't we use it and save money? This pictorial showing the building load design of New Mexico Tech. This place have both the heat exchanger and how heat is being distributed to the various smaller loops into the various offices and buildings to be used for heating and cooling the mineral science and engineering building. This is my team. Unfortunately, we didn't get the two other people there, but this is our team being there during the exploration time to gather data with relevant stakeholders. We had Jason from the facility management to help us tour the facility, gave a whole lot of understanding and how the operation. We also had opportunity to meet people like Sherry who helped. So this is how uh, cooling or distribution unit for the classrooms, the fan and coil unit and relief air. And that's what is being used in the system. Our goal is to use the system technology. What we already have, implement our system. And this is a thermal control valve that is being used for offices and also changes in order to attenuate to see how the operation in the various atmosphere, whether hot or cold, to change our temperature for us. Oh, this is wow. This annual energy consumption cost, how much we spent. If we know the energy in BTU is not important, but we're going to know how much we spend on heating and cooling. So this is a graph showing for heating, and this is a graph showing for cooling. So now we look cost per year. The cost we use in spending for this is about 700,000 a year. Looking at the mark, you realize that yeah, geothermal have a high upfront cost, but this we're going to see about 81% if you implement this system using our existing technology. Our long-term effect, we are going to achieve this economically viable heating system in the next 20 and 30 years and cutting that cost. We reduce carbon footprint since we have stopped relying on natural gas for our heating and cooling system. It's well designed and follow every required procedure. These are our references. Any question? Thank you.